Okay, so good evening, everyone. Please, I hope you're all doing well. Okay, so I'm going to share my screen so that we set the ball rolling. Okay, please, can you see my screen?
Yes, please.
Okay, thank you very much. So, over the period, we've been looking at Python programming, and the fundamentals of everything we have been doing has been covered in this structure, as you can see over here. So I'm quickly going to run you through everything we did at each chapter so that we kind of have a refresher, because definitely today, maybe in the next hour or so, we should be able to finish with what we are about to do. So we started off with some basic concepts. I think that's what we did over here, where we're looking at, okay, just using the print function. And I said the function, or a function at the time, was just um, equivalent to maybe the functionality we get from a TV remote. So every key on a TV remote was given some functionality, and we're using the print function. The print function will print whatever thing we put inside of it onto the terminal. And we saw instances where when we say print and we pass in University of Ghana, University of Ghana is going to display in the terminal. Then we said that, well, if we bring a hash in front of any line, then that becomes something the CPU not going to execute, because it is going to look at it as a comment. So it's going to bypass that. Then we went on to look at writing a first Python program. We reinforced some of the knowledge we had over here. We moved on to variables. We said that variables are placeholders for storing data in the computer memory. And this was nothing different from the variables we already know from algebra, in the sense that if we are given a word problem, Kojo and Ama were given 20 oranges to share in a ratio 5:3. What is Ama's share? You normally say, let Ama's share, or let X represent Ama's share, and maybe Y represents Kojo's share. And whatever calculations you do in your variable, the X and the Y you declared were just variables going to store the data in terms of Ama and Kojo share respectively. So we saw that, well, we can choose any name that we want, but then there are some few naming conventions, and we write the name of whichever variable that we are setting up over here, and then we use the single equal to, and this is what we refer to as the assignment operator. So basically what we have on line 2 is we are assigning this value into this variable. We also came to understand that there are some few naming conventions that is basically going to help us write our code, because if we use descriptive names and the others that we see over here, we are not going to um, 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 we are not going to run into problems in the future. We also saw that Python is case sensitive, and then also we cannot use reserved keywords in our variable names. And we saw instances where we're dealing with multiple assignments. We spoke extensively about this. And later on, we realized that we're using this, especially with the recent one we did on Friday when we're dealing with functions. Then we came to data types. And we said, well, for variables and data, they go hand in hand. The variable is a container that we label, that we put data in. And the data is actually the quantity of whatever thing we are putting inside of the variable. So in that case, we said that, well, there are different types of data that we can put in variables. The first of which we discussed was strings. And we said strings, based on what we know, okay, is a collection of characters declared in a single or double quotation mark. Later on, we came to an appreciation of when exactly we might be forced to use a double quotation mark, and when exactly we need a single quotation mark. But regardless of that, whether it is double or single, it is still going to work. We also saw that whenever you put whatever thing in a string, in a quotation mark, that's a string. We saw some few examples, and we saw that, well, to actually verify, we can use this type keyword we have over here on line 8. So that, yes, we are printing something around the department, which is a variable storing the value computer engineering. However, we just don't want to print the department, we want to print the type, the data type of the department. And we saw those data types. We also came to an appreciation of the fact that, well, we don't just have only strings, we have integers, and Python will represent integers as ints. And these are positive and negative whole numbers. So we saw those examples. We saw floating point values, and these are basically the, the decimal fractions that we have. We also saw complex numbers, and we have come to an appreciation of what these complex numbers are, because in advanced mathematics, sometimes you get to meet these numbers. Now, we also learned about a data type called a Boolean, and the Boolean basically will only store data in only two forms, either true or false. Okay, so for instance, if the question is asked, were you selected to be part of the Google machine learning program? It is just a matter of true or false, or yes or no. There's nothing in between. So we saw those ones as well. Then we came to the input function. We saw that, well, the print function is just printing things for us. So the input function can be used to input things so that the program becomes more interactive and dynamic. Now, we also came to an appreciation of the fact that, well, with the input function, its inherent behavior is like that whatever thing you put in is going to be represented or stored in your data as a string. And for which reason we could use this technique called typecasting to convert from one data type to another. So over here on line 3, we're expecting the user to enter a PIN. And we would want to believe the user is going to enter maybe 1, 2, 3, 4. That 1, 2, 3, 4 is going to be accepted through the input function as a string. So when we pass it through this int class, it is definitely and basically going to convert that 1, 2, 3, 4 into an integer before it is saved over here. And for which reason we're able to check on line 5 to verify that now we're getting the integer data types. And we saw other examples over here as we moved along. Later on, we came to understand some few characteristics of the Python programming language. And the first we discussed was, well, there's a conversation about dynamic and static programming languages. And now when we say something is dynamic, obviously, then that means it changes one way or the other. And that's the behavior or the inherent behavior of Python. Unlike other programming language, which is static, by which means if you are declaring variables like in C++ and in C, if you are declaring variables, you declare a variable with its corresponding data type. So a typical C, if I want to, for instance, declare, let's say, I'll say int x is equal to 9, then probably bring a semicolon before C will accept this. But then in the case of Python, I just have to do x is equal to 9. And Python is automatically going to figure it out. All right. Now, you also came to understand that this is an interpreted language as against compiled languages with other programming languages. Now, interpreted languages will execute the line of code line by line. So we saw in a particular instance where everything was working until it gets to where the problem is, then the code breaks. But in the case of C++ and other compiled languages, it has to compile everything and make sure that everything works before it executes. We were able to analyze that and see that, well, there are some pros and cons with each type, and realize that with Python, it kind of gives us a direct where exactly the problem is, other than compiling and sometimes you're unable to figure it out. We also saw that, well, Python is a high-level language because it has some what we call vocabulary, okay? Some human readable, like print, input, learn, and all those things that we've come to learn. And they are almost like the English language that we know. And behind the scene, it will be converted into these zeros and ones because these zeros and ones is what the CPU understand in order to communicate with the various parts or other parts of the computer. Then we looked at other things. I quickly have to run through this because we looked at concatenation, which is basically joining two or more strings together. Then we delved into string. We actually looked at the string methods. We looked at arithmetic operators, comparison operators, and all these things over here. And we're gradually building some few things because when we came to functions, we're applying a lot of things over here. So clearly you could see that, yes, we are assigning a variable, storing some data over here, but then this data is going to be as a result of some arithmetic mathematics operation over here. And in this particular one, we're basically calculating the determinant of some system of equation we saw on Friday. And then using Cramer's rule, we're able to solve that system of equation and we're able to do some computation. We also saw that, well, with functions, whenever we put a parameter, then we definitely have to put some arguments when we are calling them. And if we know for sure, for instance, if we are calculating the area of a circle or the area of a rectangle, we know that, well, these are the exact parameters that we need. Because since time immemorial, the area of a circle has never changed. That formula is still pi r squared. So we know that it is only the r, because the pi is always going to be a constant. So it is the r that we are minded about. So we put r over here, or in this case, radius over here, and then we move on with knowing that the user is only going to enter radius. But then in instances where we are not too sure, we can actually use these args. And these args is going to bundle everything into a tuple. And then when we use the quarks, it is actually going to bundle everything into a dictionary. And we saw a typical example of this the last time. Now, there's one thing I would want to touch on before we move to classes, because I want to start afresh with classes today. So in the next 5 minutes, let me just show you this. And let's just go to this particular one, probably the last chapter, but then I'm bringing this ahead of time. And these were some extras or some extra things that we needed to touch on, which we are going to look at. We have exception handling over here. So over the past few times, let's say we have something number one. And let me just say this, we are using the input function, and then we are saying that enter first number. The whole logic I'm trying to put out over here is we want to have this, so enter first number, and let me say number 2, and I'm going to say enter second number. And we just want to sum these numbers. All right. So clearly, if we leave it this way, it is just going to be a concatenation, because by default, this is going to be a string. So we have to do the typecasting. So I'll do a typecasting over here to make sure that everything that comes in over here is exactly what I expect it to be. Then I'll normally have, how do you call it, a variable called results, and I'm going to say number 1 plus number 2. And I'm going to do a printing of number 1, of results. So this is something we've done before, but then we want to look at some concept in programming we call exception handling, because this was something I left out intentionally. But then look at this. When I run this code and I type in 20 and it runs, now we're on line 3. It is asking me enter second number. I put in 40. It runs and it tells me that I'm getting a 60 over it, because that's exactly what we get when we sum 20 and 40. But then the problem is, I run this and maybe somebody types in number. Clearly, the code is going to break, okay? And I kept telling you that, well, let's pay attention to these errors we see over here. So in this particular instance, we are seeing a value error. And these errors are more or less things I'll call necessary evil, okay? Because yes, they are not too good, that's why they are evil, but then they are necessary because it reinforces our understanding with programming. Because the moment we see this and we come to read the details of this error, we know that, oh, okay, this is what we should do. So for instance, we saw with the out of index range error and all those things, and it kind of made sense, giving us a better understanding and appreciation of a whole programming journey. So now we see this value error over here, and this is something undesirable. So normally you see that with some of these computer systems, when maybe it is expecting some numerical inputs and you put in some alphabetic inputs, it kind of gives you a prompt that, well, you did the wrong thing, so do that. But then currently what is happening is the code is breaking. And if the code breaks this way, that means the user is probably going to have the system crashed, and that's not what you want. So at the back of our mind, we should know that, well, there's some exceptions that we should catch or handle. And that's why this whole concept of exception handling comes in. So this is what we are going to do. For the exception handling, we are going to use the keyword try. Now, the moment you see a keyword, you know that it is definitely something you cannot use for our variable names. And the way this one works is, well, the moment I put in try, I bring in a column over there, and then I have to indent this. After the indentation, I'm not done yet. I have to do except. So this except is also a keyword. Now I can leave it blank this way and say something like this. And we are going to see different combinations of different exceptions. So I'm going to say invalid inputs. So now I run this. All I'm trying to say is try executing this code. But then if there's an error, except there's an error, then you print invalid input. So now look at this. I put in 20 over here, then I put in 40. This one will work. So it will try everything and we are getting our results over here. But then if I run this code and then I put in the same AMA I used to put, which was crashing our program. Now when I press enter, the program doesn't crash. At least it gets to line 8, which says invalid input. And that's exactly what we see over there, because instead of crashing and telling us that there was a value error or whatever thing we saw earlier on, it is telling us that there's an invalid input. So this is something maybe the user is going to see and rather make some changes. So with the invalid input, you can put in a more descriptive something over here to tell the user that, well, the program, let's say, accepts only numeric data, something like this. So this one is more descriptive. So the moment somebody comes in here, maybe the first one is 20, but then the second one does a mistake and do, let's say, KO, then it tells the user invalid input. The program accepts only numeric data. So this one is very clear and very simple. Now let's look at something over here. Now let's say this time around, I just want to do a division. Okay, this is an arithmetic operation. So now when I do AMA over here, this AMA is going to be cut on this line, the first one. Okay, enter first AMA, and then I'm getting invalid inputs. The program accepts only numeric data. But now there's a problem, not too much of a problem, but I want us to be more pragmatic, because whichever error will be different from another. Okay, and let me give you a typical example. Let's assume we don't have this exception handling thing over here, and for which reason we have everything being showing up this way. Excuse me, just a minute. I have a call. Yeah. Good evening. Oh. Yeah, the mom also. Wonderful. Yeah, we have a call. So we are not about it. Okay. All right. Okay. Bye. All right. Sorry for the interruption. So let's say we have this, and let me just get rid of this so that everything is looking good. So this is a original thing without catching exceptions and all that. So clearly when I run this program and once again do 20, this one is dividing on line 5. I'm using the slash, okay? So if I'm to do 10, definitely we expect to see a 2.0 because that's the 20 divided by 10 is going to give us 2. All right. But then the problem is, once again, if I type in AMA over here, this one gives us a value error. So now let me just copy this one over here and let me just put it over here, value error, as a comment, okay? All right. Now let's see something else. When I run this once again and I pass in 20, and now I pass in 0 over here, then on line 5, I'm expecting to see 20 divided by 0. Mathematically, this is a disaster. This is not feasible. So when I do this, it tells me that, well, this is a different error altogether. So it says this is a 0 division error. So let me just copy this 0 division error and now put this one to over here. So depending on the kind of error, because not all errors are the same, that's basically the point I want to prove over here. So each and every error will give you some kind of warning that you need to be mindful of. So having said that, now let's look at how we solve this in a more, in a more pragmatic way. So now if I'm to do this and do this exception handling this way, and I'll come out to say, please, can you hear me? Somebody says he cannot hear me. Okay. So if somebody, if we come up to say except, and like we saw earlier on, we are seeing a print invalid inputs, okay? Program accepts only numeric data. So this is what we were doing, and then whenever we have, let's say, AMA over here, that's what we get, okay? But then the problem is not really too much of a problem. If I'm to do 10 and then do a 0 over here, it is still catching this, okay? The program is not breaking, but then the error message we are getting, our own error message, is now not making sense. Because over here, it is actually a 0 division that we are trying to do, but then it is saying that invalid inputs, program accepts only numeric data. If whoever is using our program is not too mathematically inclined, the person will still be trying to put in something divided by 0 and will still not be making sense. So over here, we can be more specific and say that, well, except if it is a 0 division error, this is what I want. So this is almost like an if-else statement. So I can also bring another except over here. So except if it is, for instance, sorry, the first one was a value error. The second one is going to be a 0 division error. Then I can bring, for instance, a more customized way. So this one, I'm going to say invalid calculation. Then I'll say cannot divide a number by 0. So now let's see. Let me just clear the screen. And now if I run this, 10 divided by 5, this one works perfectly because there's no problem. But then let's check with the first error where we are trying to put in AMA. It tells me that this is an invalid input. Program accepts only numeric data. So this one is more direct. It is only catching the value error. Now, if we try using the 0 division one, so I'm saying 10 divided by 0. This one will now tell me that invalid calculation cannot divide a number by 0. So this is basically, this is something we are going to see moving on, because sometimes you may be working with some libraries and you get some errors. And the moment you get the error, like I said, it is rather teaching you the right thing to do. And if we are also going to write your code one day, you should also find means and ways to teach others the right way to go about it. So that's with the exception handling. There are other things that we can do, but then I think this one will cover the basics of that. So having gone through that, let's quickly move on to the classes. And I think for the benefit of everyone, I think I'll have to start from scratch over here. And then let me try and see if I can get the material I worked with the last time. Okay. So let's quickly do a recap of what we did last week, because this is very, very, very important. So yes, last week we started with object-oriented programming. And this was the presentation outline, a very simple one. Start with introduction, conclusion, and look at some code implementation. So last week, we ended at the code implementation, but then we are going to start from scratch. And we are going to see that, well, when we say object-oriented programming, all that we are trying to say is, okay, well, it is a programming paradigm in which the code used to implement programming logic is based on the concept of objects. So over here, once again, I have 3 keywords I've highlighted. And in these 3 keywords, the first one we discussed last week was programming paradigm. To say this is a programming paradigm is just another way of saying this is a programming methodology. So there are some various methods in which we organize our program or we organize our code. Object-oriented programming is one of many. A typical one, which we have been using behind the scene, is what I have over here as procedural programming. And this programming paradigm or programming methodology is all about writing procedures or functions that performs operations on data. So we writing functions to calculate the area of a circle or the area of a rectangle or even the system of equations. There was a procedure. We were using Cramer's rule. We were using the normal length times breadth, okay? And we're writing everything in a function to perform some operations on the data that we were given. And we're calculating the system of equation. We put in the radius, it will calculate the area of a circle for you. So that was good. So object-oriented programming is just another one which we are being introduced to. So another keyword we see over here is the word orient. So the word orient is also an interesting one. And there are some few synonyms you see over here. So if you say something is oriented, then we are saying that, well, a synonym is align or place or position or situate. So if we say object-oriented programming, it's a programming paradigm or a programming methodology in which the code we use to implement programming logic is oriented because it is object-oriented. It is situated, it is aligned, it is positioned around the object. That means the object then becomes the integral, is like the center of abstraction. Everything we write is surrounded or situated around the object. And we are going to see that very soon. So now that we have that out of the way, we then left obviously what an object is. But then in order to understand objects, the object is something we get from a class. So a class is a blueprint for creating objects. That's so to speak that, or that's so to say that the object then becomes an instance of a class or a creation out of a class. And to understand this very well, this is what I do. We use the baking pan scenario. So in the baking pan use case, we are seeing that, well, if you are looking for a blueprint for creating objects, this baking pan can stand in as a blueprint. It is like the steady guide, okay, for which we create objects. And then the objects we can create out of this baking pan can be, of course, bread, but then we can have different variations of bread. You can have a tea bread, you can have wheat bread, sugar bread, coconut bread, butter bread, and any other bread combination that we may come up with. Now, there are a lot of advantages and, advantages with object-oriented programming. In a sense that, well, when we use object-oriented programming, it provides a clear structure for our program. So back to the baking pan. If we want structure, if we want all our bread to be in a rectangular shape, all that we need to do is just to make one baking pan rectangular in shape. And the thousands of bread that we are going to bake out of it is going to be in that particular shape. And the whole concept of object-oriented programming is basically what is the underlining principle in most of these applications that we use. Because for instance, when you, very good, all of you are students over here, so this is something we are definitely going to relate to. So when students' data is, we can say that it can be modeled in a form of objects. So every student is an object. And that object is going to have some attributes. And those attributes are going to include your name, your date of birth, your gender, and other things you provided the school whilst we are applying. And as time goes on, whilst you're a student, you are taking courses. So definitely how do you call it? The courses you took and the grades you got and everything will also be attached to those objects. Is that okay? And the structure over here is like that. If you are in the same class, unless maybe there are some electives that you can choose between A and B. But then let's assume there are no electives. If you are in the same class, it is a structure for you that has been created for all engineering students, maybe in the biomedical engineering group. You are taking these courses. So that's a structure. So object-oriented programming gives us that structure. Now, it also makes us create full reusable applications with less code and short development time. And then we can also say that it helps keep our code dry. Dry is an acronym for don't repeat yourself. And you're going to see these things in manifestation. So now let's move back to our IDE where we are going to actually write the code. So we are going to start with object-oriented programming, in the bakery, and then we'll move on to other things that going to excite you. So now let's say we have a class and we use the class keyword. If it is a function, we are going to use the def keyword, but at the class, we use the class keyword. And now I'm going to say baking pan. Once a name, or once again, I'm using a name which is descriptive. Then I bring in a column. If this was a function, I was going to bring in this parenthesis where I can put in, how do you call it, my parameters. But at least, based on what we have learned now, we are just going to bring in a column. Then the moment we have a column, the moment I press anything, we are going to have an indentation. Clearly, you could see that we get some red warnings around. Well, it is not complete once you have it this way. Okay, so over here, we get that warning. We also get that warning showing up over here. But in order to get our way around it, let me just use the keyword pass over here. All that you are trying to tell Python is, well, we'll come back to this, but then just let go of the warning. We just want to just create that class that we have. So when we do this, all that we have done is, yes, we have created a class. So we have created a class, then we can start creating objects out of the class, because the object is a creation out of the class. So now this is what I'm going to do. I'm going to say bread1 is going to be equal to baking pan. And then I bring in a parenthesis this way. Things are beginning to look interesting over here. So I'm saying that bread1, which is a variable, which is also a creation out of this class. And when I do this, it is telling me that this is a class. All right. Now, maybe for curiosity's sake, yes, I want to print bread1 and see, because that's the object I have now. So I want to print this. Now, clearly, when I run this, well, I don't think you're expecting much anyway. But then we see something interesting over here. Let me just pull this a little bit up. And all that we are seeing is, well, we see that it says that __ main _ dot baking pan object. Remember, we are printing bread1, and it is telling us that it is a baking pan object at, and this is some memory location in our computer. We don't have to worry so much about this, because Python takes care of the memory allocation, memory management. That's not part of our problem. But then the main thing I want to put out over here is we have actually created an object out of this baking pan. And then we are printing this, and indeed we are getting a confirmation that this is a baking pan object, the bread1, at this particular memory location. Okay, now before we continue, let me just go back to something we learned earlier on, so that we take inspiration from some of the earlier things we learned and come back. So you remember that when we're dealing with the Boolean operators, we saw this showing up over here where we drew the logic gates and stuff like that. Okay. Now, remember I told you about this triple quotation marks, and I said these ones can also be seen as, how do you call it? As comments, okay? But technically we refer to them as dot strings, or like some document string, basically. That's like how we call it. Now, it is very important to know that, well, we can put in some dot strings to actually help us. Because look at this. If I come in here and hover my mouse around this print function, which Python already gave me, it gives me some descriptive information about the function and what it does and all that. But then, if I'm to write my own function, okay, and let's go back to the functions that we were writing. If I'm to write my own function this way, and hover my mouse around this, my function, it doesn't give me any information. So this is where I can use a dot string, okay? So when I come inside of the function and do a triple quotation mark, it can be double or single. And I can see that, okay, this information on the function is fine, something like this. Now, when I hover my mouse around this, we now see this information on the function is fine. Good. Now, the point is, if I do it this way, this, like I said, is a dot string. So it is kind of going to be accessible to whoever is going to use the function. However, if I decide to use the hash symbol, then this one is strictly a comment, because when I come back here and hover my mouse around it, I don't get to see that help. So that's something you should keep in mind. So we can, and of course, if you are writing a very big program that probably people will be using and stuff like that, you should make sure that you have these dot strings that kind of give that information. And we are going to use that same thing over here, because over here too, if I'm to do a triple quotation mark this way and say this is the baking pan class, and I can probably use a /n. /n is basically new line. Okay, so this is going to rather break it down to a new line. Okay, say this is the Google machine learning training. So we have it this way. So this is our baking pan. So now when I hover around this baking pan, I get this information showing up. So this is a baking pan and something funny. So let me just get rid of this spaces over here. All right. So everything is looking good. And this is a Google machine learning tree. This is, I think this one is not working. I don't know. Let me just do this. Another line over here. Okay, so now we get this and we can write our own descriptive information of whatever thing that we have. Now, there's also one concept I need to take care of, okay? And this concept is very important. So now we know what a function is, okay? So let me have this, my function. And this is also going to explain some few things that we are going to work with. And let's say this function accepts A and B as parameters. And I'm going to say result is going to be equal to A plus B. We saw something similar to this. And let me say return results. It is almost like, sorry, not return results. It is almost like an English statement. So far from what we know, we understand this. Now look at this. When I hover my mouse around this, it tells me that this is a function. Okay, it tells me that this is a function. So please take note of this. Now, when I copy this, Control C, and bring it inside of the class. So I'm going to bring some code over here so I can let's go of this pass keyword and let me make sure that I do the indentation over here. So now pay attention over here. The same piece of logic. If it is outside of the class, it is called a function. However, if it is inside of the class, and it is inside because you know this function is indented inside of this class. It is inside. If it is inside of this class, when I hover my mouse around this, it tells me that this is a method. So that is why I come back to the point I made earlier on. That functions and methods are the same. However, it depends on where the jurisdiction, where it is located. And I use this example in class very often. That let's assume there's somebody in the class who, by virtue of the fact that the person is my mother's younger brother or sister, then automatically that person is more or less my auntie or my uncle. So when we go home, that person is my uncle. But then when we come to school and I'm teaching the person, regardless of the relationship that we have, that person now becomes my student for me to assume the role of a lecturer. But then my inner being hasn't changed, the person's inner being hasn't changed. But then the jurisdiction in which we find ourselves has changed. Therefore, we are going to address ourselves in a different way. So that's the point I'm making over here. That outside of a class, if we use a def keyword to write any logic, then that one, we call it a function. But then inside of the class, even if it's the same logic we are writing, this we are going to refer to as a method. So remember what I said earlier on, that the string methods are methods or are functions that are only applicable on strings. So now let's go back and see what I meant by that. In a sense that when I do name, it's equal to, for instance, Kenneth, this way. Now, this name is equal to Kenneth is based on resemblance of something we are seeing over here. And let's pay attention. See, on line 9, we are saying that bread 1 is equal to this. And over here, we are saying that name is equal to this. Now, I could have done name is equal to str, and I'll pass in, maybe leave it blank like this, yes. Pay attention very well. We are saying that name is equal to str, I've left it blank. And now I'm saying that bread 1 is equal to what I've written, baking pan, and I've also left it blank. So now if I'm to do a printing of the variable name, when I run this, I don't see anything because definitely it is blank. Okay, I don't see anything. But then if I'm to do a checking of the data type of name, I'm definitely going to see that this is actually a string. So we see a class str over here. So now this is also going to tell us something, because now if I'm to do a printing of the bread 1, the data type of bread 1, this is what I get. I get a class of baking pan. Forget about this underscore main thing. Is that okay? Okay. Okay. All right, sure. We can clearly see that there's some resemblance or some similarities that we can draw over here. So now the point I want to make is, well, when we're printing the type of baking pan, it told us that it is a class of baking pan, which kind of makes sense because we have written it ourselves. We can see that class baking pan, and we've written some code over here. Now, when we do a class of name, which is also the object. So the point I'm trying to point out over here is everything we have been doing so far was object-oriented in nature, except that I just had to hide it somewhere small for you to appreciate and understand some few things before we come in. So Python is heavily reliant on object-oriented programming. That is how it is built. So if you actually write code that reflects object-oriented programming nature, then definitely it is definitely going to be seamless. And not just only Python. I mean, most of the modern programming languages you see. So whether it is Java or C++, sorry, not necessarily C++, but then Java, JavaScript, that, and all those modern programming languages you see, most of them are reliant on object-oriented programming. So everything we did from day one, whether we're declaring a variable or doing almost everything, we're dealing with object-oriented programming. But that's not what we want. Now, the point is, the point is this code inside of an str is actually written for us. So now when I click on my mouse and hover my mouse around this one becomes more or less like a clickable link. So when I click on this, it takes me behind the scene code. This is actually part of what we downloaded when we're downloading and installing Python. Okay, and let's just pay attention over, because I mean, I'm not going to bore you with this, but you can look at the very top, okay, where my cursor is currently at. You can currently see that the Python I have downloaded, I think the other day I showed this in class, okay? It is on my users, my C drive, go to users, Lenovo. Definitely your file system is going to be different from mine, so you can do this at your own time. And currently we see the VS Code extensions, whatever Python we see over here, the distribution, and you see that we have the standard library over here. That's the std-lib, okay? Those of you who have done Python will definitely understand some of these things better. And then we have the built-ins. So this is something which is built inside of what we downloaded. And actually, it is some code that is actually written. So we see over here, class str. And almost everything you see over here, all the built-in stuff, are classes in nature. So the complex number that we're dealing with, you see that class complex. Okay, then what else? This one is the floats that we're dealing with, class floats. But now look at something interesting over here. Now let's get back to the string. You will see that this string, this class string, then you come and see def capitalized. So this is a function. The capitalized we're using, they are all functions, but because they are under the confines of strings, it was only applicable on strings. And for which reason we cannot go and use one naneba, two naneba. It was very funny when I was saying it, but I think the picture is becoming clearer now. The reason why we cannot use it, because it is under the confines of a particular class. So clearly we see that we see the capitalized over here, okay? I think we looked at some few ones. Yes, we looked at the count. We looked at the index, the isnam, and all those is digits, is lower, and all those, how do you call it? Yes, the lower, we looked at it extensively. So that's basically something we should understand, that the code that we are writing, is not as if it is something magical. The code is actually written down, and that's part of what we downloaded from the Python official website. So that's just by the way. Now let's concentrate on our own class, because our own class is very important. And that brings us to the concept of something we call the constructor, okay? So now the constructor is a method. Let's take it out. The constructor is a method. And the way I want us to relate with this is that, well, having a baking pan this way and just doing this here, then it's like, what are we actually doing with classes? Well, with classes, we can do a lot. So what we would want to do, typically do with classes is, okay, we want to organize code in such a way that we put functions that are related to a particular class or a particular something we want to create, so that later on when we create objects, we can be applying those functions or those methods on those objects. So in the case of the name is equal to whichever name we use as a string, we could apply those methods that are associated with strings on those objects. So the point is, okay, you want to create a baking pan, and want to, maybe this is a bakery. So let's say everything is digitized. So let's say somebody comes in and say, oh, I'm ordering, let's say 20 loaves of bread. That 20 loaves of bread, there's some calculation. Okay, that calculation, we can simply write a function that behind the scene, the user is just going to input the quantity of bread. And that quantity is going to be multiplied by the unit price. And we are definitely going to get the total price. But before we do that, we need to put things in order. And the functions are going to help us put things in order. Now, one of the first functions we'll talk about, like I did indicate, is the constructor. Now, this constructor method, I think it is quite descriptive. It constructs something, okay? It helps us put data together. And these data are going to serve as the attributes of the class. And that's how we define. And once it is a method, it is definitely going to have the def keyword. But then this one is a special one. So we use def, then underscore, underscore, NINIT in it. Another underscore, underscore, and then I bring in this, because this is a function. Please, this is how we write the constructor method, so that whenever Python sees this inside of a class, it knows that, okay, this is the constructor method. Now, for every method will have the how do you call it? The self keyword. And I'm going to explain this later on. But before we go about this, let's look at it. Let's assume we don't bring the self keyword, and then we do a pass over here. Please pay attention. Now, this constructor method is automatically going to be invoked as soon as we create an object. When I say it is automatically going to be invoked, this is what I'm saying. It is automatically going to be called as soon as we create an object. So as soon as this bread object was created out of this class, this constructor method is invoked. So now, this also tells us that, well, if this constructor method has a parameter, then what it means is we also need to provide some arguments when we are creating this. Else we are going to find ourselves in trouble, because this is automatically going to be invoked. But now let's look at something interesting over here. Now let me try printing bread 1. Initially, when we were printing this, we were having no problem. But now, when I print this, we get an issue over here. And this is an issue of significant interest. So now let's look at this. And I want us, in fact, this one, everybody is going to contribute. And this is what students say. I like calling their names in class, but then I think this one I have to do this. So now we see that there's a type error over here. And it says that the baking pan dot this init method takes 0 positional arguments, but 1 was given. Obviously, we can see that there's nothing over here. So it takes 0. But it is telling us that 1 was given. Is it not confusing? Oh, it's not confusing. Okay.
It is.
Okay. All right. Because clearly we are saying that if this, if this, for instance, let me just comment this one out. This method, okay, and I'm just saying pass over here. If this method, init method is not where it is currently because I've commented it, we get our bread objects at whatever memory location. All right. But then the moment we have that in action, the moment we bring this and run this, we are getting an error. It says it takes 0 positional argument, but then 1 was given. We haven't given any argument over here. Okay, maybe for some reasons, based on what we know so far, let me just start putting some few things over here. So let's say I put in Ken, because it is expecting me to put something over there. I run this, and the situation even gets worse. It tells me that it takes 0. We know that it takes 0 because there's nothing over here. But it is telling me that 2 were given. Where is the 2? Okay, let me add another one. I use my football age, 12. I run this. It is getting worse. It takes 0, but 3 were given. So clearly there's some kind of, what I would say, some ghost is doing something over here, okay? And we're actually going to catch it. So clearly it tells us that now this is what is happening. This init method expects a default parameter. And that default parameter is going to be the instance of the class. Let me repeat myself. This init method expects a default parameter. And that default parameter is going to be the instance of a class, of the class. Now, the big question is, what is the instance of the class? Based on what we learned earlier on, we said that, well, if we come to this definition that we used, we said that a class is a blueprint for creating objects. The object then becomes an instance of a class or a creation of the class. So what Python expects us to do is, well, it needs to bind whatever thing you are doing with the instance or with the object. And that's the reason why we have the self parameter over here. This is by default. Every method will have this self parameter. Every method will have this self parameter. So the moment I put in this self parameter over here, and now when I run this, it's okay. It doesn't have any problem because it needs to be binded with the object. Now the point is, inside of the class, we are going to refer to the object as self. And then outside of the class, we are going to refer to the object by the object name. And because this is object-oriented, everything is going to be surrounded around the object. So everything we'll be doing, it is either going to be around self or around bread. Because inside of the class, this is what Python wants to. Python wants to identify the object and work everything around it. Now, this self could have been anything. It could have been something like data. It doesn't really matter. It is still going to work. But just so you don't confuse other programmers or other colleagues who will be working with you, just use self and half of your problems will be solved. Okay, so now let's look at something interesting over here. Now, without this, okay, let me just comment this once again. And let me shrink this down. And let me just take this one off because this one is taking so much space over here. And let me just clear this. Okay. So with this in mind, okay, this one is going to work because we don't seem to have any problem. We are just creating our class and saying pass. So this is what we can do. Now, because this is an object-oriented programming approach, look at this. What are some of the ingredients we use in baking bread? This one has got nothing to do with Python programming, so maybe you can help me out. Let's check out some of the ingredients we use in baking bread. Yes. Well, I see flour. Yes. Which other ingredients?
Butter.
Butter.
Sugar. Yeast.
Then, we can go on and on. Is that okay? Good. So this is how I want us to look at this because this is what I do in class, and also the videos are there for you to go back. So we are going to use flour, and we are going to use sugar, and then let's just forgo yeast for now. And then let's do something we call special ingredients, okay? Okay. Okay, so you are getting eggs, yeast, a lot of, this one is the B. Foster kind of bread. All right, let's concentrate on the one we are coding in Python. This is a Python bread. So we have flour, sugar, and special ingredients. We can go on and on and on. Now, we could have said flour is equal to, and let's say with the flour, there are two types. So we have the soft and the hard. So you could have said flour is equal to soft, and we could have printed flour over here. And this is what we have been doing over and over again. So this one is looking good. But then, because we are using object-oriented programming, we cannot just say flour is equal to soft, simply because the whole programming logic is centered around the objects. So if I want to say flour is equal to soft and do it the object-oriented way, I have to say bread1, which is the object, dot flour. Now, remember what I said about the dot operator. When we use the dot operator, it's almost as if I want to go into it. So now, this whole thing on line 7 says, I want to go into the object bread1, assign an attribute flour, and give it a value of soft. That's what we see over here. And now I also want to go into bread1, assign a value of sugar, and give it a value of maybe 20 grams. Then I think the Python bread is becoming an issue, right? I can go into bread1, assign a value of special ingredients, and give it a value of, let's say, butter. So this one, we are going to get a butter bread, okay? If it is, let's say, wheat, we are going to get a wheat bread. That kind of logic is what I want to build up over here. So the point is, if I want to print some value out of bread, I can say, well, bread1 dot, I want to go into it. So I want to go into it and now see flour. And now when I run this, I'm getting soft. When I do bread1 dot sugar, like you have it this way, when I run it, I'm getting 20 over here. When I do bread1 dot special underscore ingredients and run it this way, I'm getting my butter over here. So far, nothing has changed, except that we are using object-oriented. So everything is around the object dot something, the object dot something. Even if we are doing calculation, it's going to be the object dot something times the object dot something. That's the whole point about object-oriented programming. The whole programming logic is centered around the object. So this is just bread1. Now I want to create bread2. So I come in here, maybe on another day, I still want to use the same baking pan because that's giving me the template. So I've created bread2. So now I can do bread2 dot flour. And this time around, I want to use hard flour. Then bread2 dot sugar. This time around, I want to use, let's say, 10 grams of sugar or 10 whatever quantity. Then I also want to do bread2 dot special ingredients. And this time around, the special ingredients I'm going to use is wheat. So once again, instead of just printing bread1, I can now be working with bread2, okay? And I can do a printing of, for instance, let's say bread2 dot special ingredients. And then when I run this, I'm getting the wheat over here. But then there's a big problem over here, okay? And the problem is, well, anytime you want to create a bread, we'd have to be doing that bread object dot those attributes and be assigning them and stuff like that, which is, I mean, a complete waste of our time, because when we're discussing object-oriented programming and we're concluding, the last conclusion we had over here was, well, the OOP, object-oriented programming, is going to help keep our code dry. We don't want to be repeating ourselves. Currently, with the structure in which we have our code, we are repeating ourselves, which is so unnecessary. Because the moment, for some reason, maybe I do a mistake and say bread 1 dot something like flour instead of flour, then I deviate from the whole concept of object-oriented programming having the same structure, because then in the case of bread 2, it is going to have flour, which is hard, and bread 1 is going to have flour, which is soft. I mean, it is becoming very funny. All right. And that's not what we want. So in order to get this out of the way, we rather want to have things properly structured. And that's why we are bringing the constructor method over here, because the constructor method is going to help us put things together in that structure. So look at this. So I'm going to say def. We already know what this constructor method looks like. That's what we see over here. And let me just get rid of this. And you know, the autocomplete feature is going to give you the structure, okay? So what I did basically was to do def and then underscore, and I had this. So this one was selected, press enter, and it auto-completed for me. So clearly, when I do it this way, it becomes a little bit confusing because all of a sudden you are seeing self over here. So that's the reason I didn't bring self, in order for you to see the problem you are going to run into. Because at every stage in your programming logic, it is going to be centered around the object. So your system should know which is the object. If it is outside of the class, you are going to represent it by the name of the object. If it is inside of the class, we are going to use self. So self is always going to be in the method. Now, instead of whatever thing we do, we can put flour over here, and then we can put sugar, and then finally we can do special ingredients. Let me see this properly. Special ingredients. This way. Now, when we do it this way, we are not quite done. Now, we would want to be assigning them like we saw over here. So in order to assign them, remember, if it is outside of the class, we use the name of the object, which is bread1. If it is inside of the class, we use self. So now I can say that, okay, self.flour should be equal to flour. Now look at this. Because we are passing, this is still a function, okay? And because we are passing these, this one is automatic. We always have to bring it. But these ones are the ones we are introducing as attributes. And every bread object that we will create is going to have these ones over here so that we have that structure. So there's always going to be flour, there's always going to be sugar, there's always going to be special ingredients. Just as you have your students' MIS system, every student is always going to have a first name and a last name. It's always going to have an email address. It's always going to have a phone number. It's always going to have some courses registered. And you cannot deviate from how the things is structured. And that's exactly what you want to do over here. So now when I say self.flour, this self.flour is similar to what we see over here, bread1.flour. And over here, I assign soft. So over here, I'm assigning self.flour to this flour over here. Now this flour is what I'm going to provide as maybe soft, and this will be taken here, and at the end of the day, we'll find its way here. It is almost like the function, except that this is a class. So that's the similarities or the inspiration we are drawing from here. And then I'll come in here and do self dot. For instance, sugar is going to be equal to, and this is the only time I advise students to do copy and paste, because sometimes you don't want to have a problem over here. Then I can do self dot special ingredients, Control C, Control V, should be equal to special ingredients. So now when we have it this way, then remember that this init method is automatically invoked when an object is created. So because it is automatically invoked and it has these parameters, therefore we need to provide arguments so that they'll be filled in there. And that's why I'm starting with soft. And the sugar, let's say I want 20, and this time around I want to have butter bread because I'm using soft flour. There's a lot of sugar over here and I want butter. So now this soft will, because these are positional arguments, remember what we spoke about the last time. This will be sent here, this will be sent here, and this will also be sent here. And for which reason, whatever is sent here will now be represented here, and so on and so forth. So now if I come back and come and do bread, let me do the printing first. So let me do print, and I want to do bread1 dot, let's say sugar. Remember, when I do bread1 dot, that means I want to go into the bread1 object. and I want to access whatever thing we call sugar over there. And now sugar I see as 20. If I do bread 1 dot special ingredient and run this, I'm getting the special ingredient as butter. Now, this is where the interesting thing comes in. Now, if I'm to just create a bread 2 is going to be equal to this baking pan class, then I just provide the values because the structure has now been created. So this one is hard, this one is 10, and over here, I'm going to say coconut. So I want coconut bread. This is bread 2. If I want to create bread 3 out of this same baking pan class, then the type of the flour, let's say I want soft, the quantity of sugar, I want 40, and then the special ingredient, maybe this time around, I want sugar bread. So back to the point we made over here, that object-oriented programming makes us create full reusable applications with less code and short development time. This is just a sneak peek into it. But clearly you can see that instead of now doing bread 1 dot flour is equal to this, bread 1 dot sugar is equal to this, bread 1, we are just simply writing this in one line. And we can create. Now the point is, if let's say for some reason we are saying that, oh, we need to give yeast, so all that we need to do is to come inside of this one and say yeast, and now do self.yeast is equal to this, and now just apply yeast over here. So our code is more manageable. We don't have a lot of moving parts, and things are very simple for us to handle. All right. Now, like I said, this is the method we use to kind of put a little bit flesh around our class. And that's the init method, the constructor. But then we can write a lot of methods or other methods over here. So the other method I show in class is, let's say I want to have a method called bread name. And remember, every method needs to be binded with self, which is the object. And the way I look at this is funny enough. I have a funny way of looking at this. And the way I look at it is, okay, the self is almost like the soul and spirit of the class. So any calculation is around self, which is the object. So any method should also have that soul and spirit of it. And please don't go and write anywhere that I said is the soul and spirit, just for understanding. Okay. So we have bread name and we are passing self over here. Now, what do you want to return? Okay, maybe I just want to say return something like self dot. And what I want over here is, let's say, the special ingredient, okay? So I can say special ingredient. So self is the object, and we are going into the object and grabbing special ingredients. So this one is going to work, okay? This one is going to work. So what I'm going to do is I'm going to put this in a formatted string. So let me just put this in a formatted string this way. And because this is a formatted string, I need to enclose this way. So over here, if the special ingredient is, let's say, wheat, I'm going to see wheat bread, because this self is the soul and spirit, and it is able to grab whatever attributes you assign to it. And we are getting whatever thing bread over here. So if I'm to come in here and now do, okay, I want to print something around bread 3. So I'm going to say bread 3. Now, when I do dots, that means I want to go into it. So now please pay attention to the icons we see over here, because these icons are very important. We see that clearly. We see this, some kind of, this is like a cube, okay? This will normally represent a function or a method. And then we have flour, which we have like something in a container. So these are all variables. So these are all variables. So now when I do solve the flour this way, because this is a variable, I just have to call it this way. And it's going to tell me that, well, the flour is soft. But then if I do bread 3 dots and I bring in bread name, this bread name is a function. As we see over here, it is a method within this class. And for which reason, the way we call method is we bring in this parenthesis over here to call it. So now when I run this, I see that I see sugar bread, because bread 3, the special ingredient is sugar. And this is sent in as a special ingredient over here. And then over here, when I'm invoking this method, I'm getting the special ingredients bread. And that's why you see sugar bread over here. Now let's create another method. And this method is probably going to calculate the price of bread. So I'm going to say total price. And once again, it will always take in solve. But at the back of our mind, we know that, okay, the user is going to enter the quantity of bread that he is going to. So I can say quantity over here. And over here, there's going to be a simple calculation. So over here, let's say I have a variable called total. And this total, just a minute. Yes, sir. What are we doing? Okay, Pacho. What are you trying to remember? What are we? All right, so we have total is equal to, now I want to do the calculation. Remember the calculation I spoke about. We want to multiply quantity by, let's say something. So over here, because quantity is inside of this, we can just call quantity this way. So quantity times, let's say 10. A1 bread, I think a loaf is 10 cedis. So then I can do, let's say return, and let's say over here to in a formatted string. And I can say something like the total total is equal to, and let's say bring some Ghana cedis over here, and then pass in the total variable over here. Now, because we are passing in quantity over here, which means whenever we call this method, we need to pass in a value, and that quantity will be sent over here to multiply this to give us this. So now let's say we have this bread, and I just want to print out, for instance, bread 3. Somebody wants to buy some. So the person wants to check the total price of, let's say, 30 breads. Remember, the unit price is 10 over here. So it's going to be 30 times 3. And then when I run this, we are definitely getting a 300 Ghana cedis over here. So this is how we model things. We put things in order so that Python becomes very comfortable. We can create full reusable, like I said, if we want to create a different bread, or maybe for some reason there's some tax that we need to take out of this, we can just calculate some tax and do some mechanics over here, and everything is going to work. So now let's just do that, because that one just came to mind. So let's say tax. So maybe there's no e-levy, but then this is tax, okay? So the tax is going to take in self, and let's just say, let's say the tax component is going to be, let's say the total. So the tax is going to be the total price, okay, maybe times a 0.5, sorry, a 0.05%, maybe something like that. So I can actually call this method over here. So I can call total, but then before I can call total, okay, this total price, I need to go through self, which is the object, because this is object-oriented program. So I can do self.total price. Then I'll call it this way, okay, multiplied by, let's say, a 0.05, or maybe a 0.01 is maybe just 1%. And then I'll say return, once again, put this in a formatted string and say tax is equal to, then I'll put in total over here. I'm not too sure if this is going to work, but then let's see. So we want to calculate the total tax components of, no, we are going to have issues over here because of what we have. We need to pass in the quantity, and okay, so this one is not going to work yet, but then we can no, this one is not going to work. Okay, so now let me just do dots. No. Okay. This one is not going to work because of the quantity we have over there. But then there's another example I'm going to bring up where we have other methods that we can work our way around. So that's basically the genesis or the fundamentals of object-oriented programming. Now let's look at a more practical example like the ones we dealt with earlier on. So let me just comment everything and let's start from scratch. So earlier on, we were trying to calculate, for instance, and I think this is something I brought in the exams. So in the exams, we had a problem. Let me see if I can get that showing up. I don't know. The quizzes, the exams. Okay, I think these are exams. This is anyway past questions, okay? So this is something, yes. So these are, I mean, how I structure my questions. So this is question 5. So please, those of you in level 300 who for some reason didn't write this very well, now look at the solution. Now you have been tasked to develop the Python backend code for a web application for the Lands Commission to aid in the digitalization of all lands in Ghana. The web application will enable the commission easily calculate the area, perimeter, and diagonal length of plots of land, assuming all lands in Ghana are rectangular in shape. So this is a very simple. Now follow the instructions below to develop the Python backend code using the object-oriented programming approach. So I give the prompt, and this is a very simple thing. So normally what I do is, it's almost as if I give the questions in English and I expect you to translate it in Python for me. So create a class or a rectangle class, write a constructor method in a rectangle class and assign the following attribute, length and width. Now create an area method that calculates the area of a plot of land. Create a perimeter method that calculates the perimeter of a plot of land. Create a diagonal length method that calculates the diagonal length of a plot of land. And now the question F, create an object from the class and assign the values 40 and 30 to its length and width respectively. And of course, I give the formulas over here. So I'm saying that all methods take self as its first and default parameter. So with this prompt and this hint, and trust me, I got the shock of my life, what some people were right. But that's confidential. Then we have the area of a rectangle is given by the formula this. And I'm also saying some few things over here. And this was for 20 marks. Very easy. So now let's see how we model that. So the first prompt was to create a rectangle class. So I'll say class rectangle. Now, the moment I do this, I'm almost done, okay? So I can say pass. And if I was the one solving this question, I'll actually be a little bit some way, in a sense that, okay, all I need is, the other one is question F, is to create an object out of the class and assign these attributes. Sorry, these values, okay, as arguments. So to create an object, I can say land1 is going to be equal to the rectangle class, and then I pass in the 40 and the 30. Now the other ones was to create a constructor method, okay, that's the B, create a constructor method in the rectangle class and assign the attributes length and width, because that's all I need in my calculation. So I'll come in here, create a constructor method. So I'll do def underscore underscore init and get rid of these ones. And all I need is my length and the width. And I need to do the proper assignment. So because this is object oriented, I can do self.length. And like I said, you just come and copy this and paste this over here. Then I'll do self.width, Control C, Control V over here. So we are done with the constructor method. This is where we assign the attributes. That's all. Then the next question is to now create an area method that calculate the area of a plot of land. And I've already given you the formula over here, so you can just fall on this if you have actually forgotten. So over here, I'm saying that just write the area, something like this. But then remember, I'm also saying that all methods take self as its first and default parameter. So I'm not even tricking you over here. So I'm expecting you to pass in self, okay? Then you don't pass in anything over here because the length and the width will automatically be assigned as soon as these ones are sent in there. So now I can say that, let's see, the land area. So let me call this land area is going to be equal to self dot width is going to be multiplied by self dot length. Okay, then I can say return. Then I can say, I mean, I like formatted string a lot, so let me put this in the land area, and I can say that area of plots is going to be equal to this. So it is the same calculations we are doing, but then everything is centered around the object. That's why we call it object-oriented. Okay. Now we want to also calculate the perimeter. So now I go back to the question, and it says we should calculate the perimeter, and that perimeter is given by this formula. Okay. So this is a simple one. So I can come in here and say def perimeter, and then over here I put in self over here once again. I already have my length and width, so I can say the land underscore perimeter is going to be equal to, this one is 2 times into brackets self dot length plus self dot width. It's as simple as that. Then I can do return, then I'll pass in this as an F string and say land perimeter, and then I can say perimeter of plots is going to be equal to this. Then the final one, that's exactly something we are going to learn. And we are saying that the final one is the diagonal length of a land, okay? And over here, the diagonal length is basically based on Pythagoras. So we do the change of subjects to get the hypotenuse. That's what we see over here. So we are saying that the diagonal length is going to be equal to the square root of length square plus width square. Because based on Pythagoras, the, how do you call it? The hypotenuse square is equal to, so if we on square or take the square root, that's what we get for that. But then there's a little bit of something we haven't learned, and that's why the last hint I have over here is to import the square root function from SQRT in the inbuilt math module. And that's exactly what we are coming next to, because we have some few minutes left. We are going to look at Python modules, okay? But at least for now, our code is going to work. So now let's see how this one works. So now I can say, okay, I want to do some printing over here. So maybe land one. When I do dot area and call this method, remember I have 40 and 30 over here. So certainly when I run this, I'm getting the area is equal to 1,200. That's exactly what I want, okay? Because this time this is giving me that. If I'm to do a printing of the land one dot the perimeter, which is the method, and I run this, I'm getting the perimeter is equal to 140. Now this is where it gets a little bit interesting because of some of the things that we already know. So let's assume I have this once uncommented. Clearly, we can clearly see that, let me just get rid of this. We can clearly see that we have two different classes altogether. The first we have over here, at least, with the ones we see over here, is that we have a class of rectangle, and now we have a class of baking pan. I mean, based on what we know so far, definitely the logic for each one is different. But the point I want to make here is that's the same thing that happens with if we're trying to use other methods for other data types or other classes. It is not going to work because, for instance, this perimeter method is only accessible based on how it is structured. It is only accessible in the rectangle class. And over here to this baking pan, the bread name is only accessible. I mean, this one is very clear. It makes sense because of the names we've chosen. But then in some of the things that we were trying to learn, when we're dealing with the methods that are associated with lists, they are completely different from the methods that are associated with, for instance, tuples. And they have their own unique ways of handling things. So that's what I want you to take a look at. That whenever you have a rectangle the kind of methods you can write in here is definitely going to be different. And now this is where it comes in, because you see, just under this rectangle class, we've created area, which is a method. We've also created perimeter, which is a method. And we are applying it on the same land. Just as we had name is equal to University of Ghana, we're doing the upper, the lower, and all those things on that same particular piece of objects that we saw over there. All right. Now, the next question, clearly, as we can see over here, like I did indicate, is going to lead us to an interesting concept we have over here, which is the modules, okay? And in here, we are saying that a Python module is a piece of code or file that is imported and used in another Python file. And we have basically two types. We have the inbuilt modules, and then we have the custom modules. So now let's look at the inbuilt modules, because at least Charity Begins at Home, Python has given us some inbuilt modules that we can use. So remember earlier on, we were doing some calculation of the area and we were trying to use pi. Well, we shouldn't have worried ourselves so much, because pi is more or less a universal constant. Anybody who does mathematics knows pi. And Python knows that one day, people are going to do some calculation that they will need pi. So I have to provide it for them. However, that piece of pi or that constant pi is hidden somewhere, and we just have to call it. Now, earlier on, when we're dealing with the naming conventions over here, and I said something that we cannot use reserved keywords, and I think I wrote some code that we're seeing the reserved keyword, and I said, well, we'll come back to that. Now, this is what I did at the time. I said that from keyword, import KW list, and then we did a printing of that KW list over here. And then when we ran this, we saw all the keywords. So now let's come back to this. When I hover my mouse around this, it tells me that this is a module. So once again, this is a piece of code or some file that is hidden somewhere. And because it is not readily available, we need to import it. So I'm saying that from keyword, import this KW list. So now this is what I'm going to do with pi. So I'm going to say import math. There's a module called math. Once again, when I hover around this, we have this math module. So this provides, or this module provides access to mathematical functions defined by the C standard. And there are quite a number of them over here. So over here, look at this. If I'm to do math, which is the module, which is a piece of the Python file, and I'm to do a dot, remember what I always say about the dot operator. The dot operator is almost as if I want to go into it. So now this math is a module, a piece of the Python file, which we are also going to write our own one when we come to line 7, the custom modules. So when I do math dot, I'm going into it. And clearly, I have a lot of functions over here. So whether it is something with cosine, sine, and all those trigonometry stuff, we can see them over here, okay? And quite a number of them. But then this is what I want. I want pi. And look at the symbol I see over here. Remember when we were seeing the variables, I showed you the symbol. So over here, I can simply do a printing of pi. And now when I run this, indeed, I get that value of pi, which is a constant we already know, at least in mathematics. Okay, so what I was expecting is, well, we can say import math. So I do it this way. Or I can say, sorry, let me just do a commenting of this. Or I can say from math, import pi. This is more specific. And it reads like an English statement. From math, import pi. So the math is going to be the module. So clearly, when I hover my mouse around it, it tells me that this is the module. And then when I hover my mouse around it, it tells me that this is some variable inside of that module. And we are going to create our own module very soon. So now, if I now want to do a printing of pi, because I've already imported pi, I don't now have to do math.pi again, because it is already here imported. So when I run this, I get the same results. So this is what I want. Now, the math module, no, once again, when I press on the control key and click on this, it opens behind the scene the math module. And behind the scene, the math module, you see that I have pi being said that this is a float, and you can see that it has a lot of functions over here. So the cos, all the cosine, the trigonometry stuff, okay? And not just that, if we want to look at factorial, we can just call the factorial function over here. But then we have to make sure that we use it whenever we call the math module. If you don't have the math module, it's not going to work. So for instance, if I don't have this imported, I cannot say print pi. Python is going to definitely ask me, what are you talking about? There's a name error. Pi is not defined. Even if I do print math, okay, dot pi, I haven't imported math over here. So this is completely alien. But then when I come and say import math, now Python understands that I've now sought permission and brought that math module over here. So now when I do this, this is going to work. So now let's see, because it is only when we write our own modules that some of these things are going to become very clear. So I have this as app.py, okay? Now let me create another file. I'm going to call this ml.py. So I have ml.py and app.py. So now I'm going to clear everything I have over here in app.py. No, in ML, let me go into ml.py. And let's say, let's have a constant like we have in the case of pi, okay? And let's say we have a constant, I'm thinking of one, none is coming. So let me just see, okay. So let's see, cos is going to be 1, 2, 3, 4. So this is a constant or a variable we have over here. So I can come inside of this app.py. And just as we did with import math, I can say import ML. Now look at this. When I hover around this, it tells me that this ML is a module because it is a piece of Python file I'm importing and using in another one. I'm importing ML, which is a separate Python file inside of this app.py. So now when I come and do printing, or for instance, ML dot, I want to go into it. If I go into it, I have that variable called cos over here. So now when I run this, I get exactly what we see over here, which is a 1, 2, 3, 4. So that's behind the scene what has been done for pi. And I could have done it the same way of saying from ML, I want to import cos. And once again, when I hover around this, it tells me that this is a module. And when I hover around this, it tells me this is a variable. Similar to what I have over here from math, import pi. When I hover around this, it tells me that this is the module, math module. And when I hover around it, it tells me this is a variable. So we are kind of modeling our understanding of modules to what already exists. And that's how you reinforce some of these things. If you know how it is built, you can actually get a better precision of it. So this is how it goes. So once again, we can say from whatever, do this. Now look at this. Now, with regards to the math module, okay, which is the inbuilt one, let me just quickly touch on that. It is not only pi we have in math. So I can do a comma, and there's another one we have over here as par. So instead of, let's say, let me just use this one, this simple example. So let's say 2 raised to the power 3, we can do it this way. Very simple, we get our 8 over here. I could have used the par function, so I can say par, then I provide 2, 3 this way. So this one is also going to give me the same thing, where we get 8 over here. So in that same sense, the question I was actually trying to ask of them is that, well, remember to import the square root function, which is sqrt, from the math inbuilt module. And unfortunately, some people were not able to. We did this in class actually, okay? So all that I was expecting students to do was to come here into the classes and say that, okay, because I'm going to import it at the very top, because it needs to be at the very top, I can say from math, import sqrt, which is the square root. Some were actually drawing the square root on the sheet of paper for me. So over here, we can come back and come and say that, okay, and we can even import the power over here because they are all inside of math. So over here with the diagonal length, the formula is always going to be simple. I can say dag length, and once again, it's going to take in self, and then I can say land diagonal length is going to be equal to, well, I don't even remember the formula I provided it over. So it's going to be the square root of the length squared plus width squared. So over here, all I need is SQRT because I've imported the square root of length squared. So I can say inside of this, I can say self dot length, okay. But then because I want to square this one, I can do self dot length times self dot length, or better still, I can bring in the power function. Then this is going to be self dot length raised to the power 2, like this. Then I can do plus another power, and I can do self dot width. Then I can do comma 2 over here. Then I can finally come in here and come and do the returning. So this one is very simple. So I can say return, and then in a formatted string like we always do, I pass in the land diagonal length over here and give it some flavor. So I can say diagonal length of plots is going to be equal to this. Yes, Enoch, I can see your hand up.
Hello, please can you hear me?
Yes, I can hear you.
Hello.
Yes, I can hear you. I can hear you. Please, you can speak.
Please, you can speak. Okay, so in place of the self, can you use the when you use the class name itself, will it still work in place of the self?
Okay, so in place of the self,
Self dot length.
okay.
Okay.
So in place of the self, when you use the class name, okay, when you use the class name, it is, I'm tempted to say certain things, but it is not it is not the right thing to use, okay? Because I think, let me show you this, because I think in the video and in the class, I used that example, but I just wanted to skip that part because that may not reflect over here. So now let's say this is the baking pan, okay? And in the baking pan, we want to have, let's say, unit price is equal to 10. Now, what I have over here is what we refer to, this is just a simple variable, okay? But then because it is within the confines of this class, baking pan, we refer to this as a class variable. So this is a class variable. Now, this class variable, we are saying that unit price is equal to 10. So we can then say that, well, instead of just doing this hard coding over here, I can say we can just multiply by the unit price. But that's not what I want so far. Now, look at this. We have created this bread object, at least bread 1. And, okay, everything is commented out over here. So let me also comment these ones so that you don't have any problem. So we have created this bread object, bread 1 over here. Now, look at this. If I come in here and see bread 1 dot, I want to go into it. I can have access to, for instance, the unit price, which is a variable. Is that okay? Then because this is a variable, I don't have to call it. I only call it this way if it is a function. So now look at this. If I run this, this one is going to work. So I get 10 over here. So everything is looking good. Now, I can also do the baking pan, which is a class. Dot, I want to go into the baking pan. I also have access to the unit price over here. So once again, like I said, I'm answering your question, but then I was tempted not to go there. So once I do baking pan dot unit price, when I run it, I'm still getting 1010 over here. So the point is, yes, indeed, we can use or we can have access to anything by either the class name or through the object. So over here, we're accessing the class variable unit price on line 45 through the object. Then on line 46, we are using the class name. Now it is going to work until you start doing something we call inheritance. Okay, because object-oriented program, one of the advantages and usefulness of it is, okay, so for instance, let's say with the University of Ghana, MIS, okay, I want to believe if things are modeled in object-oriented programming, we are going to have, let's say, an object for person. And that person is going to have attributes like name and other things. And then another class like student is going to inherit from person. Another class like lecturers is going to inherit from person. And because the way things are structured in that linkage, inheritance, it is prudent in a way that, okay, if we try assessing things through the object, then what it means is through the class name, then what it means is a lecturer or a student can be accessing things a lecturer should only have access to, like inputting results and stuff like that. So if it is through the object, then it is specific because the object is always going to be a creation out of that class. But then if it is a super class, then it becomes a whole lot of a mess. So for now, it is possible, but then let's keep it this way because this is the proper way of actually writing code. Please, is it clear?
Yes, it's clear. I was just concerned because, for instance, if we want to call on the methods all together in different classes and then self coming in, I was thinking, won't it interfere with the other ones we are calling in different classes? That's what I was asking.
All right. So, I mean, that also answers itself because once it is within the confines of a class, we can even use the same variable names. But then if it is inside of a class, it is always going to be within that scope. The other one is not going to interfere. So let me just quickly wrap up because we have just 4 minutes. So the module, like we said, we're doing the important as we clearly saw that's happening. So now let's look at, let me concentrate more on the custom module. So now we have ML over here. We have this. Now let me just create a function. So I have function, let's call this addition, so add function. And this add function takes in A and B. And then it returns A plus B. A very simple one. We already know what this one will do. So let me just duplicate a number of these. So Control V, and let me just change this one to, for instance, maybe sub function. For this one to do a subtraction. So let me just do a minus over here. And let me call this, let's say, div function. And this one will do a simple division. All right. So these are all functions within the ML class, plus this constant variable we have over here. So I can come inside of the app.py. And now I can see that from, now when I say from ML, import, let's say, course. This course is going to be that constant. Now I can say, I also want to bring in the add function. And for which reason I can use the add function and stuff like that. So now if I do add function and pass in 3 and 6, remember we are returning over here. So before we see it, we need to print it out. So I can come in here and do a printing of everything we have over here. Once I run this, I get a 9 because that's exactly what we want. So you can see that we can write a lot of code over here and now just be calling them over here so that we structure our code very well. Now, let me quickly touch on this because libraries are very important. Now, many a times, a lot of the things that we talk about, Dr. Mill spoke about, that we'll be dealing with some optimization, some learning rates and all those things. Yes, that's exactly what we are going to do. But we are not going to write a lot of things from scratch. In fact, if you write things from scratch, you are completely wasting your time. But of course, at the beginning, we are going to write some few code from scratch to actually see. Then we start using libraries because libraries are going to help us. So imagine I give 2 contractors some job to do. And contractor 1 decides to use what I call the everything from scratch approach. Contractor 2 decides to use, well, let's get everything from the market. So the everything from scratch approach is, well, contractor 1, because he's using everything from scratch, decides to go to where they are winning the sand to go and take the sand over there. Decides to mold his own blocks. Decides to go to the forest to go and lumber timber. dry it, take it to the sawmill, do whatever, decides to go to the stone quarry site to get some stones, and even decide to go to his own aluminum mining site to get his own aluminum. You can imagine where this is getting. Then the contractor two decides to use the everything from scratch. The already things in the market. So contractor two just goes to the block factory. I need 1,000 pieces of blocks. Within a week, that one will be given. Contractor two goes to the timber market. I need wood 2x4 and plywood instantly. So definitely contractor two is going to work as much faster as possible than contractor one. And that's essentially what libraries gives us, because there are things that are already existing on the market. We don't have to reinvent the wheel. We have to make good use of our time and focus on the kind of problem we are trying to solve and now apply those libraries. So let me just show you quickly, because our time is up. But then the libraries are essentially what you are going to use moving on. So if you are to go to the python.org, okay, the python.org, this website we came the very first day when we were doing the installation of Python. There's this external link over here, which is the PyPy, which is the Python package index. When I click on this, it takes me to more or less an external branch version. And it says, this is where whatever library or package you are looking for, you can get it over here. So it says find, install, and publish Python packages with the Python package index. So over here, everything we need. So let's say we want to do something machine learning. I can, if I'm a complete novice, I can come in here and see some machine learning libraries and a lot of things over here. I don't have to reinvent the wheel. Remember all the algorithms we spoke about, the decision tree, the support vector machine, the neural network. You don't have to write everything from scratch. You can use these libraries. So over here, I just have a brief synopsis of everything we have over here. So now I have this library. This is a library I built myself. So let me just show you. We have the KBT car. I know some of the third years and second years are saying this one will show his library. Yes, I need to. So this is a very simple library. It is not anything too crazy, but then just so you know, this is my name showing up over here. Kenneth Bruni is the author of the library. So this library, just as other people have done, I also wanted to put something out there to also test some of the few things. But then it basically does the simple things that we know, okay? So there's a add numbers function, subtract numbers function, multiply numbers, just as what I wrote over here in the ML class. These ones were the things I just wrote in there, packaged it and put it on as a library. And I did a recording of a video on that. That was actually the main purpose. Okay, so this was something I did in, 2021. That's a long time ago. So that's the library I have over here. And then I'm just not the only one. But then once you have a library, or you know that this is a library you are working with, then we have this command, pip install, and the name of the library. So pip install and the name of the library. So normally you can just come and copy this to your clipboard. You come into your terminal and then you do a pip install. So let me just clear this one. So if I do pip install and I type in kbt car, I already have it installed, so definitely it's going to tell me requirements already satisfied. Once again, you need internet for this web. So it tells you requirements already satisfied. And then once you have it, I can now import it as a module over here. So I can say from kbt car, import whatever, or I can say import kbt car over here. So clearly, this is a library, but then when I hover around it, it tells me that this is a module because it is a piece of Python file that I'm importing and now going to use over here. So now let's see what we have in kbt car. So when I do kbt car dot, I want to go into it. This is all object oriented. Now add numbers. What do? I just pass in number 1 and number 4. So 1 and 4, and I just want to have this printed out, and I'm expecting to see 5. So when I run this, I see sum is 5. Okay, what about I want to do divide? So I see divide numbers float. So divide numbers float. When I run this, I get the quotient float is what I see over here. So 1 divided by 4, that's what I see. And we can go on and on and on with this. So once again, the libraries are a lot. So this is just one of it. Now this is Flask. Yes, my brother, Enoch, I see your
I
hand
just
up.
want to ask Python relate these files when importing a model. Isn't that they must be in the same folder? How is that relation done? And then also with the one you just imported, did you code it such that it can take multiple numbers or it's just two numbers?
Okay.
And if you can see the behind the scene of that code.
Oh, okay, yes.
it's
So the
just
behind,
imported.
yes. So let me just answer the behind the scene first. So the behind the scene of that code, once again, the moment you have any, Python file imported as a module, you can do control and click on it. And this is the behind the scene. So once again, you see, because see the path over here, it actually goes up and add up to, how do you call it? The things you have. Okay, the things you already have installed. So this is the behind the scene code. This is just add numbers. So once again, your second question is just taking two numbers and adding them, dividing them, multiplying them. Like I said, the main logic or the main things I was trying to implement over here was actually to see how we package a file and upload as a package or a library. That was the main thing over here. All right. Then I think the other question was, which one was that? If you can remind me.
I was asking how Python is able to link the files when imported. Is it because they're in the same folder somewhere or?
Okay, all right. So this one is very simple because it is in the same. This one is very simple because it is in the same folder. Okay. But now let me just create another folder over here. Remember, app and ML are in the same folder. But let me just create another folder over here and let me call this folder, let's say, which name? Let's see, let me call this folder. Oh, let me call this folder machine. So this machine is a folder. And let me grab this ML and put this ML inside of this. So I've moved this. So now this ML is inside of this machine. And if I want to import ML over here, now you could remember that initially I could have just done import ML. Now currently when I do it this way, I'm going to have a problem because it is not seeing ML because the directory has changed. So now in order to get this, I can see that this ML is inside of this machine folder. So now I can say import machine. Now this machine is now going to serve as a module. So now I can do machine, which is a module. Now I want to go into it. So once again, the dot operator, when I go into it, I have ML over here. And now when I go into ML, so let me just do machine.ml, and I can do another dot. And I think I have course over there. So now when I do this, we are having a lot of dots over here, but then that's basically the whole concept. So remember, this ML is inside of machine. I have course variable over here. So now when I do machine, which is the module now, the folder, .ml, I'm going into machine. I want to go into ML. And inside of ML, I want to go into the course variable. Now, it says what? The module has no attribute ML. Okay, no problem. Now, look at what I'm going to do. I can say from machine, import ML. So I'm saying that from the machine folder, import ML. Now I can do ML dot, and this one round, I have course over here. So now if I'm to do a printing of this course and run this, I get this. So now the whole point is, it also depends on how your files are structured. It also depends on how your files are structured. If they are in the same directory, you don't have to be navigating through a lot of things. But then if they are hidden somewhere, which a lot of the libraries, that's how it is. So you can have a library that you have some things hidden inside of certain things, and others you are going to see all of them. But then just to say this, I think if you go through my YouTube channel and actually watch the video I have on this, I think it will do you a lot of good, because we are done with the Python. The next thing we'll do is to the next thing we'll do is to actually look at the various libraries and how we apply them. So in here, we can, I think this one is exception handling. So yes, this is the Python libraries. And I think the modules, that was in part 1 and part 2. So you can actually check these ones out. Maybe by Friday before we come, if you have been able to watch this video, I think it will answer some of the things I was probably rushing through because of time. Okay, I think our time is fast spent, so we can call it a day. But then if there are any questions, I'll gracefully answer those questions before we end. Please, are there any questions? Is it okay for our understanding, or it is too much and it will take time for it to sink in? I just want to get some feedback.
I think it's okay.
It is okay.
Yeah. And as you said, it's a bit too much, but I'm sure gradually it will sink in with
Exactly.
practice.
Okay.
I guess I'm speaking for everyone then.
Okay. Okay, no problem. But like I said, this is just scratching the surface. Once we get into the model development, you realize that not everything we actually learned in Python that we are going to apply, but so you know that, okay, this is also possible. We can also do it this way and stuff like that. All right. So in the absence of any questions, I think we can end it here. The video will be recorded. I mean, we are recording this and I'll make it available hopefully tomorrow online. Okay, so we can meet, God willing, on Friday. And like Dr. Mill said, Friday is going to be our last day and we are going to conclude on everything. So thank you very much and see you next week. On Friday, sorry.
Thank you.